Hi everyone, let's take a look at the following word problem. A fixed volume K of metal is melted down and made into a solid consisting of a cylinder of radius r and of height h, surmounted by a cone. The cone's radius and height of which are both equal to r. Determine the ratio of height to radius when the surface area is a minimum. Step number 1. Draw a diagram. If you look at this from a two-dimensional perspective, meaning a side view, there is a cylinder at the bottom and a cone on top. So it's going to look roughly something like this. Now, of course, you can write a let statement. Let R and H be the radius and the height of the cylinder in units. Now, if you go back and you label this, there's the height, there's the radius, just like that. Now, in addition to this, if you think about the cone, the height of the cone, it's also equal to r. So let's label this r. It's right here. And again, I want to make sure you can see what I'm seeing here. The cone has a height and radius, which are the same. So again, this is specifically for the cone. Now, before we keep going, you can see there's an additional let statement that we have to write down. This is going to be useful in a second because you're looking at the minimum surface area. So we're introducing S, which, by the way, if you look at this, is going to be the square root of r squared plus r squared. That's going to be 2r squared inside a square root. So this is going to be root 2r. So again, let's write a second let statement. And this is going to be let S be the slant height of the cone in units. And again, to be very clear, this is a two-dimensional diagram, a side view of the cone and the cylinder. Before we start optimizing this, let's write down the equation of constraint. So we use a different color here. Write down the equation of constraint, EOC. If you go back to the first sentence, the volume of this shape is going to be K. So V, which stands for volume, equals to K. And of course, if you think about the volume of the cone plus the cylinder, this equals to pi r squared times h. That's going to be the volume of the cylinder at the bottom, plus 1 divided by 3 times pi r squared times r for the volume of the cone that is surmounted. So again, don't forget this equals to K. And of course, if you collect like terms, on the right-hand side, it's going to be 1 over 3 times pi times r to the power of 3. Now, in a moment, you will discover that we're going to isolate for h just because it's a lot faster than isolating for r. So again, we're going to come back to this in a moment. Leave some space. Let's use the first color again. Now, what are we trying to do here? Write down the word minimize. Again, this comes from the last part of the question when the surface area is a minimum. So it goes to minimize the surface area. And of course, if you look at the shape, again, there are three parts you want to think about. There's the bottom of this shape, which is the area of a circle. There's the lateral surface area of the cylinder and the lateral surface area of the cone. So if you write this down as a sum of three parts, again, the first part is going to be the area of a circle. That's going to be given by pi r squared. The second part is going to be the circumference times the height. And of course, that's going to be 2 pi r, which equals to the circumference times the height. Last but not least, if you think about the lateral surface area of the cone, that's going to be pi times r times s. So I'm going to draw this out again for you on the side. So I'm going to draw a rough and ready kind of diagram. I want to color code everything so you can see what I'm doing here. So if you wrote this out, right, in terms of the three parts, this bottom part has a circle, which is right here. Then the middle part is going to be this lateral surface. Again, there's the height, there is the circumference, and the lateral surface area of the cone right there. And again, if I label this, this is going to be R, that's going to be S, that's going to be R, and so on. Now, again, we wrote down the first equation of constraint. I call this the mini equation of constraint, which was the fact that the slant height equals to root 2 times r. So in a moment, I'm going to take that and plug it back in. So this is going to go back to here. Now, very quickly, you will see we want to express the surface area only in terms of radius. So look what happens. The surface area equals to pi r squared plus 2 pi r times h plus pi times r times, in brackets, root 2 times r. And again, if you want to express this only in terms of radius, then we need to go back to the equation of constraint and isolate for height. So again, I'm going to switch back to blue. And if you go back to the equation constraint here, we can isolate for h, and we're going to leave it in this form. There's a reason for this. It's all going to make sense at the very end. So height equals to k minus 1 over 3 times pi times r to the power 3 all over pi times r squared. We're going to put a box around this, and we're going to come back to this in a moment. So we're going to plug it into the following line. So again, if I go back to orange, the surface area equals to pi r squared plus 2 pi times r. And if you plug it back in, this is going to be k minus 1 over 3 times pi times r to the power 3 divided by pi times r squared plus root 2 times pi times r squared. So again, we're expressing the surface area only in terms of r. Now, before we take the derivative, set it to 0, solve for r, plug it back in. Extremely important that you collect like terms and try to simplify this as much as possible. So let's go slow and methodical. Surface area is going to be pi r squared plus, again, what I can do, and I'll use a different color for you, I can cross out 1 pi from the top, 1 pi from the bottom, 1 r from the top, and there's another r at the bottom just like that. And I'm also going to expand this. So if you look at this carefully, there's a 2. I'm only going to expand the 2 to the top. Make sure everybody is in the moment. Nobody's left behind. 2k minus 2 over 3 pi r cubed all over r plus root 2 r squared. Again, let's keep going. This equals to pi r squared plus 2k divided by r minus 2 pi r cubed divided by 3r. Again, if you think about this carefully, there's a fraction divided by a second fraction, which means you take the first fraction and you multiply by the reciprocal of the second fraction. So basically that radius r at the bottom will be together with 3. So you end up with 3r just like that. Plus root 2 pi r squared. Again, we're not ready to differentiate, set it to 0, and solve for r yet. Let's keep going. Surface area, SA equals to pi times r squared plus 2k divided by r. All I'm doing here is I'm crossing 1r from the top and 1r from the bottom. This will give you a square just like that. Again, we're going slow and methodical. And at any given time, if you want to press pause and try to go through some of the mechanical steps, when you press play again, I'll be right here. Now, again, our goal is to collect like terms. And here's the way you can look at it. I think about this as 2k divided by r on its own, which I'm going to copy in a moment right there. And I think about everything else as one term. So what I mean is this. When I think about the first term, it's r squared. The third term is something r squared, and the final term is something r squared. So what I'm doing is I'm going to collect them and factor and put them as the first part. So again, there are four terms. I recognize this, but I'm thinking about it from the following perspective. So again, I'm copying 2k divided by r at the end. What I'm doing is I'm keeping r squared on its own. I'm going to I'm factoring r squared essentially, but I'm putting it at the back instead of at the front. And in brackets, I'm going to copy pi minus 2 over 3 pi plus root 2 pi. Now to combine this, I need a common denominator. So I can express pi as pi divided by 1, root 2 pi is root 2 pi divided by 1. The common denominator is going to be 3. So the surface area equals to, I'm going to multiply the first fraction by 3 divided by 3. That's going to be 3 pi divided by 3. I copy the second part, minus 2 pi divided by 3, plus, again, I'm multiplying the top and the bottom by 3, 3 root 2 pi divided by 3, all in brackets, times r squared, plus 2k times r to the negative 1. The negative 1 is going to be useful in a moment when you find the derivative. So again, we're almost ready. If I look at this carefully, this is going to be 3 pi minus 2 pi, which is basically pi, plus 3 root 2 pi all over 3 in brackets, and I multiply this by r squared plus 2k times r to the negative 1. We're now ready to take the same 3 steps when it comes to optimization. So again, you take the derivative, you set it to 0, and you solve, in this case, the radius. S a prime, and I'm going to write it out here. This equals to, again, when you differentiate r squared, that's going to be 2r. I'm going to bring the 2 to the front, copy this, times r. When you differentiate 2k times r to the negative 1, that's going to be negative 2k times r to the negative 2. The next step is I'm going to set this to 0. Now again, there's so many steps we're thinking about here. One of them is you can cross out the common factor of 2. So when we switch colors, you can cross out the 2's. If I rewrite this entire next step with positive exponents, that's going to be pi plus 3 root 2 pi divided by 3 times r minus k divided by r squared. And my goal is to solve for r. And I also want to think about the opposite of 3r squared. So what I'm going to do is I'm going to multiply everything by 3r squared. And of course, on the left-hand side, it doesn't make a difference. This is still going to be 0. On the right, there's r squared, though. So pi plus 3 root 2 pi, r times r squared is going to be r to the power of 3 minus 6, or I don't mean 6, I mean 3 times k. In order to solve for r, I have to bring everything to one side, divide, and take the cube root. So when I bring negative 3k to the left, that's positive 3k. I copy everything else. In a moment, I'm going to divide by everything in the brackets. The moment is here. The opposite of multiplying by pi plus 3 root 2 pi is to divide by pi plus 3 root 2 pi. And now r cubed equals to 3k divided by pi plus 3 root 2 pi. And the opposite of r to the power 3 is you take the cube root. Again, unlike a square root, there's only one case. So you don't worry about the plus and minus like you would when you're solving for x squared. This is simply going to be r equal to the cube root of 3k divided by pi plus 3 root 2 pi. Now, we're about halfway. Remember, the goal behind this question is not to find all the unknowns and the minimum surface area and so on. Your goal specifically is to find the ratio of the height to the radius. So again, if I go back to the very beginning here, right, the question here says, determine the ratio of the height to the radius. That's all we're looking for. Everything else we don't have to focus on. So here's what we're going to do next. Height to radius. Let's write this down. So therefore, if you think about the ratio, and specifically we're looking for height to radius. So therefore the ratio is height to radius, or the ratio of, I should write it like this actually, let's try again. Therefore the ratio of height to radius equals to, again, if you go back to the equation of constraint, the height is given to be k minus 1 over 3 pi r cubed divided by pi r squared. So that's the height. Divided by, make this as long as possible, the radius. And of course, radius is the same as radius divided by 1. Again, let's make sure this is clear. Height was given to us right there. And the radius basically is r, and I'm keeping it as r for now. Let's talk about what we're looking for. Let's begin with the end in mind. So your end goal is to have some kind of number. It could be 5, root 2, 7. It's going to be h to r to some number. And you will discover that it is independent of k, which is the volume in this case. So what we're going to do is we're going to simplify this. Then we're going to plug in radius and express the final answer as a number. There should be no k or r or h at the end of this. H to r equals to a number or a ratio, right? And if I remember right, I think it's root 2 to 1. Let's find out. Again, when you think of a fraction divided by a second fraction, that is the same as the first fraction multiplied by the reciprocal of the second fraction. So it's going to be k minus 1 over 3 pi r cubed divided by pi r squared multiplied by 1 divided by r. Again, if you keep going, this equals to k minus 1 over 3 pi r cubed divided by pi r cubed. Let's break this into two different parts. In the first fraction, that's going to be k divided by pi r cubed minus 1 over 3 pi r cubed divided by pi r cubed. In a different color, I'm crossing out pi r cubed in the second part. Now, look what happens. Again, the first fraction, this is going to be k divided by pi times, again, r was the cube root. So notice the cube root and the cube. And if you go back, this is the cube root of 3k divided by pi plus 3 root 2 pi minus 1 divided by 3. So again, you can cross out the cube root with the cube. And if you keep going, we're almost at the end here. This equals to k divided by pi, which is the same as pi divided by 1, multiply by 3k divided by, now notice I'm going to factor the common pi at the bottom here, right? So the common pi at the front and brackets is going to be 1 plus 3 root 2, just like that, minus 1 over 3. Again, a couple of things you can do. First of all, pi divided by pi, you can cross out, that equals to 1. Now, I'm also going to rewrite k as k divided by 1. So again, my goal is to express this as one fraction. And the fact that it's a fraction divided by a second fraction, you take the first fraction and you multiply by the reciprocal of the second fraction. And again, there's a bracket like that, divided by 3k minus 1 over 3. Again, I can cross out k divided by k. That's going to be 1. We're so close. Look at this. One fraction, there's already a common denominator of 3. This is going to be 1 plus 3 root 2 minus 1. Again, cross out the 1 minus 1. Yes, 1 minus 1 is going to be 0. This is grade 12 math. And now, therefore, let me cross this out as well. There's also this 3 divided by 3, which equals to 1. Therefore, h to r, which is the ratio of height to radius, equals to root 2 to 1. I hope this makes sense.